we're looking here at integration of even and odd functions. Now, with a change of variable, sometimes integration can be difficult even with that change of variable. Occasionally, you can simplify the evaluation of a definite integral over an interval that's symmetric about the y-axis or about the origin by recognizing that the integrand is either even or odd. Okay? So if we look at this first figure, notice that this is an even function, right? It's the same on the left and right of the y-axis. It has y-axis symmetry. Notice that this one is an odd function. It has origin symmetry, which means it's the same in quadrant 2 and quadrant 4, those alternating quadrants. Now, something really interesting about this. Notice that if I'm looking for the area of this curve, so I'm looking for the integral from negative a to positive a, it would just be the same as 0 to a times 2, right? Because it's just that has symmetry. Now, what about here? If I have this and this, notice that this one is positive and this one is negative. They're exactly the same. They're just going to cancel out to be 0. So that's going to give us two brand new things that we can remember, and that's that if f is an even function, if we evaluate it from negative a to a, so this is like negative 2 to positive 2, it's always those opposite sides of 0, then it's just 2 times the integral from 0 to a of the function. We're just going to take from 0, because a lot of times doing it from 0 to a is much easier. It's an easier integration. And we just take that and multiply it by 2. If it's an odd function from negative a to a, then we just know straight off that's 0. So the question is, how do we know if something is even or odd? Well, to be even, f of x has to equal f of negative x. So if I plug negative x in and I get the exact same thing, I know it's even. This is things like exponents that are all even. We're talking about trig functions that are even, which would be cosine and secant. Those are all even things, right? So those are good places to start. So odd function means that if I plug in negative x, I get the exact same thing, only everything is opposite signed. And this would be when exponents are all odd, or trig functions like sine and cosecant, tangent and cotangent. Right? All of those are going to be odd functions. Now, if you start messing with combining some of these things, then you really are going to have to go back to these original definitions to kind of figure out whether they're even or odd. So here we've got one. We've got sine cubed x cosine x plus sine x cosine x. And I need to know, well, first off, I've got to evaluate this. I don't know how to do this, right? I don't know any way. I could let u be sine, but then what's going to happen? Well, actually, I can. Let's do it two different ways. Let's look at it and see, can we determine whether, since this is sine cubed, let's start by negative pi over 2 to pi over 2. We can factor that cosine x out. So we've got sine cubed x plus sine x times cosine x dx. So let's let u be sine. Then du equals cosine x dx. Hey, there it is. So now what have I got? I've got the integral from negative pi over 2 to pi over 2 of u cubed plus u du. So this is u to the 4th over 4 plus u squared over 2 from pi over 2 to negative pi over 2. Right? No. What do we not do? We don't want to have to do a back substitution. Let's change our limits of integration. So sine of negative pi over 2 is what? 0. Sine of pi over 2 is what? 0. I don't even have to do this anymore because I know right away that anything evaluated from 0 to 0 or any number to itself is automatically 0. Right? Remember, if the top limit and the bottom limit are the same, it just goes to 0. But now this lets me think, well, maybe this is an odd function. So let's check it out. Let's do sine cubed of negative x cosine of negative x plus sine of negative x cosine of negative x. So here, a cube and a negative, so this is an odd, sine is an odd function, so I know I can pull the minus sign out. The minus sign does not get eaten because that's odd, so negative sine cubed x. Cosine does eat it though. Here the sine brings it out, minus sine x, cosine eats it. So if I factor the negative sign out, I get negative sine cubed x cosine x plus sine x cosine x. Same thing as this, only difference is it's minus sign, therefore it's odd. Odd being evaluated from negative to positive is 0. If you have any questions about this or any of the others, please just shoot me a reminder or ask questions in class.